Today's problem is 2D difference array. Difficulty is medium. You are given a 2D integer matrix size n by m and a list of q operations, q being some number of operations. Also a 2D matrix. Each operation is represented as an array. V is a value. And you have R1 and C1, which is the top left cell of a submatrix. You have R2, C2, which is the bottom right cell of the submatrix. And for each of the Q operations, add V, the value, to every element in the submatrix. Return the final matrix after applying all operations. First of all, let's take a look at the method signature here. You can't see it. All right, here it is. So we are given the original matrix. Here we are given an array of operations here. Now it does say return the final matrix, but actually they want it returned as a list of lists, not as a 2D array. All right? What else do we need to know here? Well, there are some examples. Here is wait a second here. It's kind of hard to read this. Hold on. What if I opened it up a little bit like that? Oh, okay, that's better. So let's say we started with a matrix like this one over here. And we get an operation like this. The value is 2. Top left corner is 0, 0. Bottom right corner is 1, 1. So that is what you're seeing here. And add 2 to everything. So that encompasses these 4 squares. Initially they are 1, 2, 1, 1. After the operation they are 3, 4, 3, 3. There's one more example. The value is -1. Top left corner is 1, 0. Bottom left corner is 2, 2. So that is these 6 squares right here. 3, 3, 0 is going to become 2, 2, -1. 4, -2, 2 is going to become 3, -3, 1. Okay. N by M, number of cells and number of operations will be somewhere between 1 and 10 to the 5th, 100,000. R1, okay, so this is just assuring us that the rows and columns in the operations are going to be valid. They're going to be within the range of the matrix. And the value of the cells in the matrix will be somewhere between -10 to the 4th, 10 to the 4th, 10,000. Expected complexities, n by m, and auxiliary space, yes, n by m. Okay, good. Topic tags. Prefix sum, yes. Inclusion, exclusion. I haven't heard that term, but I mean, I kind of know what it means. Okay. So this problem, you see a similar problem, I think, more frequently with a single dimensional array, just a 1D array. And again, you get a series of operations, you get a value, and you get a range of cells. Now, the obvious approach to that, or the naive solution, I don't really like that term, but is to just apply every operation. So you get an operation, you get a value, and you get a range of cells, and you add the value to every one of those cells, and then you go to the next one, and that's designed so it always times out. It doesn't work that way. So the way to do it that does work is to have a prefix sum array, and you get an operation, you get a start, you get an end, you get a value. All right, so in the prefix sum array, you put the value in the starting cell, and then you subtract out the value. You put the negative value in the cell after the end of the array. So then in the prefix sum, you add everything up. You put X in the start cell, everything else is zeros, and you go X, 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 you get the whole thing, and then, negative X subtracted out again at the end. Now, you may have overlapping intervals. I mean, it doesn't matter. But you'll be able to do all the updates with one pass through the array. Compute the prefix sums and then just apply them to the array. So that would be linear, and that'll work. We're going to do the same thing here, although it's a little bit more difficult. But the idea is we are going to create a difference matrix. Every operation, we're going to go through all the operations. The first element is the value. Then we have R1, C1, R2, C2. We are going to add the value to the top right corner of the diff matrix. Well, the top right corner of the submatrix. Okay? And then we're going to subtract it out again. Where are we going to subtract it out? We're going to subtract it out. Let's see, top left, the top right, we are going to subtract it. So that would be, in this example here, operation 1, we would subtract it here. That's this, as long as it's in range. We're doing a range check. Bottom left, we'll subtract it out. That would be this cell here. And one more adjustment that we have to make for this cell, because this cell is at the intersection of the column and row where we did the subtraction. That's two subtractions that are going to wind up hitting this cell. We don't want that, so we have to add it back in. That is what is happening here. We're going to add it back in to compensate for the double subtraction. Okay. Same thing here, although in this case there is no subtraction, because there is no top left cell after the submatrix, and there is no bottom left cell below the submatrix. There's no cell over here, which would be bottom right. Okay, what else? Create prefix sums for the rows. That's what we're doing here. Create prefix sums for the column. That's what we're doing here. Apply the diff to the original matrix. Well, we are doing that, but they want the result in an array list. So what we're going to do is we are going to apply the diff to the original matrix, but we're going to put the results into array lists. Okay, that should solve the problem for us. And let me scoot that over so you can see everything. All right. So let's try it. All right. So I encourage you, and I didn't do it because I think it would be, it would take too long, and I mean it would just take too long for you know, in comparison to the value that it would provide. But I would encourage you to try a couple of try their sample here, create a diff array, fill it in, compute the prefix sums, just a simple 3x3 array with a couple of operations. Merge it with the original matrix, and you will see how this you'll see how it works. So, all right. Please like the video, subscribe. I will send you problems of the day. We'll send subscribers problems of the day. Did I mention the subscription is free? Anyway, that's it for this time, and we'll see you next time.